Okay guys, in this video I'm going to be showing you how to create number 3, the roller lever. This part, if not done correctly, will kick your butt, so make sure that you follow along with this video and click where I click. Click on ENUS and choose the metric folder and standard IPT. Start a new sketch on the XY plane, and the first thing that we're going to draw is a circle right here representing the hole that is 14 millimeters in diameter. Now we can go ahead and start adding our lines, giving us a general shape of our object. I'll add the dimensions in a little bit. I'm going to add an arc and make sure that the tangent symbol that you see right there pops up, and when that does, go ahead and click and then continue drawing the general shape of this object. Once you have this drawn, and you notice that these two lines don't quite connect, go ahead and select your coincident constraint and lock them into place, and this is the general shape of our object. Now we can go ahead and start dimensioning. Our first dimension that I want to add is where the bottom of this line is in relation to the circle. That line is 14 below where the center of the circle is. Once you have that, let's add this dimension here, that's 7. This right here is also 7, and it has an angle of 45, and this has an angle of 45. Now we can go ahead and dimension from top to bottom, and that will be 32. I then want to locate where this is in relation to the center circle, and this is 14 away, and that locks all of this into place. The next dimension I need to add is this angle right here of 10. So this radius down here, we will change that in a little bit. And one thing that is kind of unclear on the drawing, but that is something that we can figure out, is that this endpoint of this top line lines up perfectly with the center of this circle. So I'm going to choose my vertical constraint, choose that endpoint, and choose this circle, and everything moves with it. I can readjust this and move this over so that way it kind of matches what I originally had, and dimension from top to bottom. This is 57, and from left to right, this is 81. Okay? This line that's at an angle should be 5 and have an angle of 45, or 135, which is opposite. From top to this endpoint there, that is 24. Bottom line here to this point there, that is 19. And everything is starting to take shape the way that it should. And this diameter here, the radius, should be 29. And all I need to do is give one last dimension, and everything should properly lock into place. One thing that I'm missing is the fillet that happens here. So I'm going to go to fillet, change my radius to 5. One thing again that isn't marked in the drawing with a dimension, but is kind of inferred, is that the center point of our arc is in line with this line right here. So I'm going to go to horizontal, choose this, and choose this center point, and that locks into place. And then I can go ahead and lock this by using coincident to lock this point in with this line. One last thing that we're missing is the circle that goes here, and this has a diameter or a radius, a diameter of 11 and is located 14 from this edge and 24 from that edge. Go ahead and finish your sketch, and we are going to extrude this. We're going to do something different. We're going to extrude this asymmetrically because there is a cutout that happens, and I'll explain later why we're doing it this way. The first distance that we are going to change, or we're going to add, is 43 minus 12. The second distance is going to be 12. So as you see, we can go in one direction, 43 minus 12, and then 12 in the opposite direction, which gives us our overall front to back depth of 43. Now let's go ahead and make a few cutouts before we continue with the next set. So I'm going to make a rectangle like so, and a rectangle like so. I'm going to go to project geometry and dimension. From here to here, this is 52. And I'm going to use my collinear constraint to line this line up with this line. Once you have that, go ahead and finish your sketch. Choose the rectangles that we created, and this is cutting into the part 43 minus 24. Now we have to make the cutout that happens right here. So this is why I did something asymmetrically. Remember, I always tell you to use your planes to your advantage. The XY plane, because we extruded asymmetrically, the XY plane lands exactly where we want it to land, where that cutout is going to occur. So we can right click, go to slice graphics, and all we see is just this. Make a circle that has a diameter of 82, because that is 41 multiplied times 2. And we are going to line up the center point with this edge here. I want to highlight or project geometry of this line and draw a line straight up from that line, anywhere on that line, 36. And I want to make sure that this end point touches this top point here, and that is where the circle will touch right here on this angled line. Now go ahead and go to extrude, and we are cutting out this part 24, and this part is complete. When you guys use your title block, remember that the title block is defaulted in inches, so we want to change that over to the metric system. So go to Tools, Document Settings, and change the default standard for annotations to ANSI mm. Apply and close. Now we can place our views, our front, our top, and our right side view. I want to go ahead and add our center marks. It is now your responsibility to add all of the correct dimensions. Make sure that your number of dimensions match the number of dimensions on the original drawing. If you guys have any questions, please let me know. and I'll see you guys in the next video.